Hello. In this video, we're going to go ahead and look at graphing a logarithmic function. So when we want to graph the logarithmic function using transformations, and then we want to graph the parent function. The parent function is not given. I will give that to you in a second. And then include any asymptotes on the graph and label, and also state the domain and range. So I'm going to go ahead and look at the parent function. And the parent function is just y equals log base a half of x. So the parent function for any logarithm is going to be whatever the base is. So log base a half of x. Creating an xy table. -1, 0, 1 for the y's, with a 1 right there for the x's. Now the negative means I flip the base. 1/2 flipped is 2. 1 means I keep the base, which makes this 1/2. Good. Also, we have a vertical asymptote of x equals 0 for the parent function. So we're going to have the following. So x equals 0 there. We have 2, -1, 1, 0, 1/2, 1. And notice that this function is technically a decreasing function, which will look like that. Awesome. So this is y equals log base a half of x. Good. And now let's look at the transformations. We have a horizontal translation, or a horizontal shift of -1, and a vertical shift of -2. So let's look at these. That is a horizontal shift of -1, sorry. And what that does is it moves it left 1 unit. We can create a new table for this if we want. So log base a half of x plus 1 there, xy table. Same things, because we're moving along the horizontal, that means that the y's stay the same. And the x's, we will subtract 1 from each one, which makes this 1, 0, -1/2. Then we have this -2 at the end. Now that -2 is outside of the argument, it's outside of the logarithm, which means that this is a vertical translation, or a vertical transformation of some sort. Now the -2 is a shift because it's out there by itself. If you had a number in front, say 2 in front of the logarithm like that, that would be a vertical stretch. But we don't have anything like that, so we're not going to have that here. So that would be a vertical shift, and it's a vertical shift of -2, which of course moves this down 2 units. And of course we can create a new table. Y equals log base half of x plus 1 minus 2 at the end. And we're going to go back to the blue function to look at these. So the x's are going to stay the same here because we're moving down 2 units. So we're going to repeat the 1, 0, and -1/2. And the y's are going to have each one subtracted by 2. So -1 minus 2 is -3, 0 minus 2 is -2, and 1 minus 2 is -1. Good deal. And at this point, we can also find the vertical asymptote. And that's wherever the argument is equal to 0. So that gives me x equals -1. The domain occurs wherever the argument is greater than 0. So that means that x is greater than -1, which would make that -1 to infinity. And the range will always be -infinity to infinity. Good deal. And let's plot this. First of all, the vertical asymptote of x equals -1. And then the 3 key points. 1, -3. 0, -2, -1/2, -1. And then basically just connect everything. There we go. And that, of course, is y equals log base 1/2 of x plus 1 minus 2. There we go. Alrighty. Well, I believe that's it for this particular video. I'm going to go ahead and end it here. I will see you in the next one. Have fun.